This is lesson 10-1, the Pythagorean theorem. First thing we need to do is review a little bit of middle school material. We have special names for the parts of a right triangle. The two shorter sides are called a leg, and we label those with the letter A and the letter B. It does not matter which one you call A and which one you call B, as long as you have the two legs labeled A and B. The longest side is called the hypotenuse. First of all, that side is always opposite the right angle. As you can see, I have the right angle in this corner, and there will always be this symbol in the corner where the right angle is. The hypotenuse will always be opposite of that. A good way to remember this is to just draw a nice diagonal line here right there, and it's an arrow that points directly at the hypotenuse. The hypotenuse is labeled with letter C, and that forms our Pythagorean theorem of a squared, which is the square of the one leg, added to the square of the other leg, b squared, and that sum will always be equal to the hypotenuse squared, c squared. So the procedure for taking care of problems like this is to first plug the numbers that you have into the formula, and you're always going to have two to plug in, whether it's A and B, A and C, or B and C. And then from there, you're going to solve the equation for whatever the missing part is. Always remember that the opposite of squaring a number is taking its square root. Here's some examples for you to try. Pause the video at this point to give yourself a chance to try them on your own. For the top example, A is equal to 10 and B is equal to 24. So in the Pythagorean theorem, I'm going to plug in 10 for A and 24 for B. At this point, I will evaluate 10 squared and 24 squared to get 100 and 576. I'll add those two numbers together to get 676. And to find C, I square root both sides. And since we're working with geometry, only the positive root is the root I want to look at. And that makes C equal to 26. For the bottom, we plug in for B and for C, and we evaluate the square root of 5 squared, which is 5, and the square root of 4 squared, which is 16. And so at this point, I want to subtract 5 on both sides. And that gives me A squared equal to 11. And then I'll square root both sides. And since the square root of 11 is not very pretty, we can just leave it as such. So A is equal to the square root of 11. Here's a word problem example for you to try. Read it and pause the video at this point to give yourself a chance to try it on your own. So an artist is cutting a piece of paper diagonally, the length of which is 8 inches and the width is 6 inches. What will the length of the cut be? So since we're looking at the diagonal, that means the right angle. I'll draw a picture of it. Here's your piece of paper. And paper is always rectangular. So when we cut it on the diagonal, your right angle is here, with the width being 6 and the length being 8. So this is what we don't know on the diagonal. And that's going to be our hypotenuse. So 6 squared plus 8 squared equals x squared. We'll evaluate 6 squared and 8 squared to get 36 and 64. We add them to get 100. And then I square root both sides to get x equal to 10. And I follow it up with a conclusion statement that the length of the cut will be 10 inches. If you're having any issues with this portion of this lesson, please make sure you are emailing me or consulting me in class.